This video is sponsored by Kodeco.com.
Hey, what's up everyone? Vegetarian Zombie here from Learn, Create, Play with another episode on C#. Believe it or not, we are diving into your first most important data structure in C#, the array. Now, before we explore this topic, please give me a like, and hey, if you are finding this content helpful, make sure to subscribe as well. It really helps the channel. Also note, I'm currently in the process of transcribing these videos in article format. If you are interested, check out learncreateplay.games. Okay, arrays are a key component in software development. You may be wondering, what is an array? You probably already know. Let's think about solar power. Oftentimes you'll hear about a solar array. Well, what is a solar array? It's a collection of solar panels grouped together, arranged in rows and columns. With that in mind, you can see an array as a collection of related data, arranged in a nice row. Let's take this example. Imagine you are a math teacher who just gave your students a pop quiz. You could put each grade in a separate variable. This may work for a few variables, but what if you have a class of hundreds? Rather than putting them in a separate variable, you can put them in a singular array. Okay, let's work through this. First, we defined an array with square brackets. The brackets are placed after the type, followed by the variable name. This means that only ints can be put in the answers array. If you try to put the string in the array, you'll get an error. Okay, now let's add the quiz answers. Here we've defined an array that contains 4 scores. Oftentimes, you won't know the values when you're assigning it to the array. In such cases, you designate the size of the array. Notice that we have a new syntax using the new keyword. This keyword really comes into play when we get into objects. In this case, we are creating an empty array that can contain 100 ints. Mind you, it can only contain 100 ints. Should you need to store 101 ints, you'll need to create a new array. So you have your array. The big question is how to read and write values to it. When you put a value in the int array, that value is stored in a spot in the array known as an index. Also note, when you refer to a value in an array, you call it an element. You would think the first place in the array would be index 1, but in the computer world, it is index 0. Now we access the index by way of the brackets. Here we set the first element to 55. Now we set the second element to 45. And here's the third, and so on. The key thing to note is that you must start counting at 0. It will be confusing and you will make errors, but hey, that's part of the process. Okay, as for accessing the element, you just use the brackets. Arrays are known as a type of data structure. These data structures allow us to organize and access data in different ways. The array is actually built into the language of C# and is used as the basis of other data structures. One such data structure is the list. It works just like an array, except you can add, remove items from it without needing to worry about the size of it. Typically, you'll work with lists over plain arrays, but arrays are a fundamental part of the C# language. Now, Unity makes working with arrays pretty easy, but before we cover that, here's a word from my sponsor, Kodeco.com. Kodeco is a website that aims to teach coding by actually coding. From videos, articles, and even live boot camps, Kodeco will jumpstart your development career. Throughout the years, a lot of you have reached out to me about my teaching style. I try to be open and accessible to all skill levels, and I think I've been successful. That's the result of having worked with Kodeco for the last 10 years. I'm actually the first employee. I started my journey with Kodeco back when it was known as raywinderlich.com, building out the website and as an article editor. Then I grew the Unity team over there and spent the following years creating video tutorials on a whole variety of subjects. Now I manage both the Flutter and Android teams. These teams are composed of passionate developers like you. They've learned the topic, mastered it, and now they teach other developers. I learned all my techniques and skills from the developers on the Kodeco teams and by learners like you. We learn, we practice, and we teach. We do so in a friendly, supportive manner. We aren't judges, we're coaches looking to take your skills to the next level. That's the ethos of Kodeco and what I do. So if you like this course and you are looking to explore a related field in technology, head over to Kodeco.com. It's the same teaching style, and who knows, in a couple of years, I'll be working with you on your own Unity course. Okay, to get started, open your current project in progress. Create a new C# script and call it myArray. Open the script and add the following. Return back to Unity. Let's get to work setting this up. Select the text game object. Remove any previous scripts from it. Now attach the myArray script. Now select the button game object. Add the text game object to it. Then select the show message method. Okay, we are good to go. Head back to your script. Let's define an array. In the last episode, we used review scores. Let's do that again. Here are some actual scores from Alien Isolation. Yes, these are real review scores. Now, some of you may be scratching your head and not just at the scores. You may have forgotten the purpose of the letter F after the number. Let's delete it for a moment. Look at that. The moment we delete the first F, we get an error. It says literal of type double cannot be implicitly converted to a float. Remember, we are declaring an array of floats, but C# considers any decimal number to be a type of double, like so. If we want to use a float, we need to put an F after the number. It basically tells C# that yes, we have defined a double, but we are actually using it as a float instead. When making games with Unity, you'll be using floats all over the place. So you'll run into this error a lot. Now, why use floats than doubles? Well, floats are a 32-bit number and a double is a 64-bit number. The 64 bits allows us to store a very high number, but with games, we don't need that level of precision. So using floats is a basic optimization. Okay, let's define a string array. Look at that. We've created a new public empty array. Save your file. Switch back to Unity. Select the text game object and look at the inspector. Look for our component. We have a reviewers field. We can now add items to it. Expand the list and add the following. As you can see, you can configure arrays in both your code as well as the Unity editor itself. Now switch back to code. Add the following. The counter will keep track of the current review that we want to print out. Remember, we always start counting arrays at 0. We are designating this as private, so we don't want it accessed by anything except the script. You'll learn about public and private in detail in an upcoming episode. Now add the following in show message. Here we've captured the current reviewer and the current score. Now let's print them out. Save and switch back to Unity. Run the game. Press the button. We get our first reviewer and score. Press the button again. We get our second, and our third, and our fourth. Awesome. Now for giggles, click it again. Nothing happens. Yet look at the bottom of the Unity window. There's a red message. Red things are bad. Click the message to open the console. The message says the index is out of bounds of the array. Here's what happened. We started the game, our counter was set to 0, which indicates the first element. We printed out the text and incremented the counter. We did this 3 more times. At the end of the 4th time, the counter equaled 4. When we pressed the button, Unity tried to get the 5th element, but the 5th element didn't exist. So when it says the index was outside the bounds of the array, it means we tried to get an element of the array that didn't exist. That's the meaning of the error. Okay, we can fix this by using the length property of the array. This lets us know how many elements are in the array. Arrays are objects, and again, you'll learn about objects soon enough. Switch back to the code. In show message, add the following to the very top of the code block. Here we check to see if the counter equals the length of the array. If it is, we reset the counter to 0. This is where you can easily get confused. Remember, the array length lets us know how many elements are in the array, which in our case is 4. The counter is the current index, which starts counting at 0. This means in our case, the first element is 0 and the last element is 3. So if the index ever equals the length of an array, that is 4, we've exceeded the size of the array. So we reset it to 0. Okay, save the code, switch back to Unity, run the game. Now click the button. We can cycle through all the various review scores, and when we reach the end, it starts back at the beginning again. Now, there's a logic error in that code. Right now, we are testing just the reviewer's length, but not the score's length. What if the score's length is actually less than the reviewer's length? Switch back to code. Let's delete the 8.5 from the review scores. Okay, save, head back to Unity, run the game. Press the button 4 times. It fails because the array sizes don't match. That is, the reviewers and the review scores are different lengths, so it messes up our code. Return back to Visual Studio Code. Add the following. Now that's some code. Here we are using Unity's math library. In this library, we are using the min function. The min function takes two numbers and returns the lowest number. Notice the min function is prefaced with mathf. This is Unity's math library, and you'll be using it a lot throughout your Unity career. Just note, I won't cover Unity's libraries in depth in this course. In the follow-up course, we'll actually put mathf to use by creating a twin-stick shooter, and you'll learn about all the various library features. Now, update our code to use the number of items variable. The number of items is the lowest amount of items. This means we can never exceed the bounds of any array. Save and return back to Unity. Run the game, press the button, and keep pressing it. Now we have our rotating list of review scores working again. Nice job. Okay, now that you've been introduced to arrays, it's time to put them to the test. For your challenge, I want you to create an array that contains the 3 top scores in Donkey Kong. You can get them by doing a quick internet search. Average them out and print them on the screen. Note, you'll need to convert the integer to a string to print it on the screen. To do this, you can call toString on the actual number or an integer variable. Don't worry if this confuses you. We'll be diving into object-oriented programming soon enough. Try doing this in code and also doing it in the editor. Pause the video now and try it out. How'd that go? Hopefully it wasn't too hard. Let's try it out. Open up Visual Studio Code and add the following. Notice I'm making the numbers readable by using an underscore. C# just ignores that. It's only for us humans. These are the high scores at the moment I recorded the video. They've probably changed since then. Now add the following. Don't worry if your implementation looks different. I expect it does. As you can see, we needed the toString on the average to convert it to a string. Notice for the average, we divided by the high score's length. Remember, the divide equal is equivalent to the following. It's just shorthand. Now let's save, switch back to Unity. Run the game. That's a big number. Now let's try it with the editor. Switch back to Visual Studio Code. Update your code to the following. Save, switch back to Unity. Select the text, and you'll see our values are still included in the editor. Run the game. Press the button, and we get the same result. Nice job. Arrays are incredibly useful, especially when combined with loops. And you'll see that all in action in the next episode.